We've just finished all the TBSS preprocessing for our fractional anisotropy data sets. And now all we got to do is run some statistics, make some nice figures, get the publications, and not necessarily get money after that. That's the one thing they don't tell you. Just getting published doesn't mean you're going to get money. Wish they would have told me that a long time ago. But we can still get to that step where we can generate some nice figures and do some statistics. So if you're ready to do that, let's proceed. So now we are within this stats data set, and what we're going to do is we're just going to set up a GLM just like we would with any other type of analysis. Okay, so we just want to set up a design and a contrast file so that we can basically carry out our contrast. That sounded kind of circular, but whatever. Okay, and once you load up GLM GUI, select higher level design because we are carrying out a second level analysis. We have all of our subjects processed. There are only 6 in this example data set, so you would change that based on how many people that you have. Next, click on Wizard just to make life easy, and 2 groups unpaired. We're just contrasting 3 people in each group against each other. So a number of people in the first group, 3, process, and everything gets generated for you. Last thing here, go to contrast and just bring this down to 2 because we're not really interested in the group means for their own sake. Now this first contrast is going to be the younger minus the older group, and then the second one is the older minus the younger group. Okay, so you just have to make sure you know which subject belongs in which group before you carry this out. But that's the way they're set up, and we're going to save this out as design. Okay, so once we have all that, we have a bunch of different files now, design.con, and also we're also going to want to do design.mat. Those are the 2 files we'll need to run randomize. And the actual command is randomize, spelled the English way with an S, just in case you're wondering. And we're going to give it an input of that all FA skeletonized, okay, that output from our last TBSS_4 step. And for an output, let's have this be the TBSS prefix and M be the mean FA skeleton. Okay. And lastly, disease is going to be that, D is going to be, I almost said disease, D is going to be design.mat, and T is going to be design.con. Now what they recommend in the documentation is because there's so few people here, only include clusters that have a threshold of say 1.5. Okay, so a cluster forming T threshold of 1.5 basically. Kind of an awkward pause while we wait for everything to finish. Okay, so now we actually do have some cluster corrected maps. This TBSS cluster core P T-stat 1. Okay, so this is that first contrast that we carried out where we're looking at younger folks as opposed to older folks, and we're comparing their tractography. Where is the diffusion coefficient, in other words, significantly greater for one group as compared to another? So the last thing I would do, because if you just load that up, it's going to look like 1 voxel thick. Okay, it's just going to be projected onto that skeleton, which is just 1 voxel thick. And to make a nicer figure, we're going to be using TBSS fill. Okay, and we're going to give it that first contrast image of younger versus older people. And we are going to set a threshold. This is going to seem kind of weird. I think we've talked about this before, but for FSL, what they usually do is they do 1 minus P instead of just a P value. So basically what this is going to do is it's only going to show clusters which have a significance level of P less than 0.05. Okay, and we're also going to load up the mean FA. And lastly, we are going to call this TBSS cluster core P T-stat 1 filled. And once that's done, we can load that into FSL view. Okay, it sounds that I was getting kind of angry. All right, awesome. So we have that filled image. Took me a while. That filled image. I made a little typo. But anyway, we will load that up. And again, we could project this onto a standardized space to make the. Actually, let's do that. Let's do that first. Let's open a standard. Let's open, let's see, M&I. This is good. This is really good. And then on top of that, we can add that filled image that we just made. Okay, I'll just take a second, and you know, it's already been color coded, which is nice. So yeah, so basically what we're seeing here is any places in a contrast of young minus old. So we're seeing differences in white matrix photography between those two populations, or those two groups. Great, so we've just finished the entire FSL tract-based spatial statistics tutorial. Again, don't think that you're just limited to using TBSS or just the FSL tools. I know a lot of people, and by a lot I mean like a couple, I can count them in one hand at least, that use, say, FSL for the pre-processing. They think the pre-processing is great, but to do things like fitting tensor images, creating the skeleton, other things, there are a lot of packages out there. So I mean, I referenced some of them on the blog. One of them, a popular one, is called Tortoise, I think, is pretty good. We might get into those at a later point, but basically I just want you guys to get some sense of how all the steps fit together, what they're supposed to produce, and then what the end result should look like.